Hey guys, and welcome back to the Earth Science Review. Today we're going to be doing a lesson on the solar system. So I want you to take a look at these two diagrams, and I want you to think about which one is a better model for our solar system. Which one represents our solar system better? Take a second. Did you say the diagram on the right because the sun's at the center? If you said that, then you're correct. The diagram on the right represents a heliocentric model with the sun at the center, helio standing for sun and centric standing for the center. The diagram on the left represents a geocentric model, geo standing for Earth at the center, geocentric standing for Earth at the center. This is what people used to think our solar system looked like, but with the discoveries from a lot of great scientists, we found out that the heliocentric model is actually what our solar system is. All the planets revolve around the sun, which is the most massive object in the solar system. So our solar system looks a little bit like this. All the planets revolve around the sun, and they each have their own individual orbit, and they don't really cross paths ever. But I want you guys to take a look at these planets, and I want you to think, do you notice anything strange? Well, if you notice, the first 4 planets are very small compared to the last 4 planets. And in fact, scientists have divided the 8 planets into 2 separate groups, like that. The planets on the left are called terrestrial, which means like Earth. They're smaller planets, they're more dense, and they're made of rock. And we happen to live on Earth. The planets on the right are called Jovian, which means like Jupiter. These planets are massive, they're very big, they're less dense, and they're made of gas. Just think a massive gas giant. Alright, so now that we got terrestrial and Jovian planets out of the way, let's take a look at the characteristics of the solar system diagram on page 15. I want you guys to notice, what do we see here? What's in the rows of the chart? What are in the columns of the chart? Right. In the rows of the chart, we have individual planets, including and it includes the sun and Earth's moon, which are not planets, but they're part of our solar system. It has the planets' names, and then in the columns here at the top, it has the different characteristics that you might find. What is one characteristic that increases with distance from the sun? I want you to take a second, look at the diagram, and tell me what is something that increases as you get further from the sun. Did you say period of revolution? Because then you guessed right. As a planet gets further from the sun, the period of revolution gets longer. We can see Mercury, which is the closest to the sun, has a period of revolution of 88 days. If we go all the way down to Neptune, which is the furthest planet from the sun, we see that it takes 164.8 years for Neptune to get around the sun one time. So as you get further from the sun, the period of revolution gets longer. This is an image showing you Earth and Mars, and as you can see, the circle, the path, the orbit that Mars takes around the sun is much bigger than the path that Earth takes because, well, Mars is further from the sun. So just to review, we live with the heliocentric model, which means the sun is at the center of the solar system. There's 2 types of planets, terrestrial, which are Earth-like, and Jovian, which are Jupiter-like. Each planet has unique characteristics, which you can find on reference table page 15. And planets that are further from the sun, they take longer to revolve or go around the sun.